What's up, YouTube? In today's episode, we're going to be talking about the core principles of API design. So, what is API design and what is an API? Today, we're going to be talking primarily about class design, method design, system design, and services, web API, services design. They're all connected. So, I'm not going to be calling out one or the other specifically, but if I feel the need to call something out specifically, I'll do that so you know what I'm really talking about. To be on the same level playing field or to level set, for me, a system is the entire system, whatever you're building, minus the front end or the UI or the the MVC or whatever it is. So the system is for me a black box, and that system has a certain API that has been provided to you by way of a domain facade that is public, so you can access it from the outside of the assembly or the DLL. For me, that's the API of the system. What's going on behind that facade, I don't want to know. But that API design also is important. And then the things that you might use to interface with that system, such as a console application or a web API application or a MVC application or an Azure worker role, web role, a Windows service. All of these things are a service interface layer, SIL, or a service interface layer. That is a layer that interfaces with your service, in this case, the system or the application. So the other aspect is when you design a system, the system as a whole is not aware of its context. It doesn't understand that I'm going to be running in the context of a web application or a web API application or a console application or a worker role, Azure worker role or a web role and so on. The system is self-sufficient, fully functional, but has no understanding or notion of the context in which it is running. And it's not supposed to. Therefore, it gives you the ability to use that same black box. You probably see a black box here now. Are they seeing a black box here now? Yeah, okay. So there's a black box. Well, it's not black. Okay, there's a box. There's an application box, right? Okay, there's an application box. And a bunch of other boxes, I'm sure. And those other boxes are primarily the service interface layer. Building a system that is agnostic of the context in which it is running is important. Thereby, it gives you the ability to slap on any service interface layer, any of these things you see over here, as a way to interact with any one or more. So it's not like you're limited to just one. You can slap on the same black box. You can say, okay, I want to use the same black box as a Windows service, for those of you who know what a Windows service is, or a web API application in the context of an ASP.NET or ASP.NET Core web API. By the way, if you want to know the roles and responsibilities of a controller, which is key to this discussion, I won't be going into the details of that in this discussion, but please take a look at it over here in the link above. Make sure you understand the roles and responsibilities of a controller, because that will play into the idea of what I call a system. Right? The web API application is not your system. That's just a service interface layer. It's a way for you to interface with your service. So now once we understand this black box that I keep talking about, or the system, which is void of any UI, not to say that eventually a UI is, of course, the most important aspect about a system, since that's what your users are interfacing with. For the context of this conversation, for me, the system is this black box that does not have a way to interface with it. And whatever you use to interface with it is a service interface layer. So if it's a WinForms application, did you put that? Okay, you did. Oh, just now. Okay, so put it like over here somewhere. WinForms application. They're still valid, by the way. In fact, then the .NET Core team is moving WinForms to cross-platform. So you can actually build desktop applications on other platforms. But it won't be called WinForms, would it? Anyway, class design, method design. It's all connected. See, in my mind, if you can design methods correctly, then you can design classes correctly. And if you can design classes correctly, you can design systems correctly. And if you can design systems correctly, you can design APIs correctly, your services correctly, and microservices, and so on and so forth. That's a whole other conversation. Services and microservices and all that BS. In this episode, we're going to be talking about designing an API. That API could be for a class, it could be for a system, it could be for a service, whatever, right? It all starts from the names. Names have to be clear and well thought out. Please spend time picking up the right name. The name should indicate clearly what that method is doing, what service it provides, what feature it provides. And if the service that method says is doing A, then the implementation should not be doing A and a B or A, B, and C. It should just do an A. And going back to method design, this is all part of the programming with intent idea that I have. So if you haven't watched the video on method design, programming with intent, method design, link up here, please take a look at that because that's the precursor to this conversation. I'm going to make a lot of assumptions about the fact that you've watched that video because that's a whole long video all by itself just on method design. And it goes into implementation as well. In this conversation, I'll bring up a few things that are key just to kind of round out the whole thing because I'm talking about the core principles in this case. Names are important. Arguments. What about the arguments? With the name, you can understand, it's easy to learn about your system, whether it's a class or a system or a web service. Right? It's easy, given the right name, your consumers of your classes or systems can easily understand what it is exactly that method is doing or what that system is doing, right? When I say it's easy to understand, the naming should also be consistent. So for example, if you say add customer, then you can't say insert order. If add customer means you're adding a customer to your system, then you should say create order or add order, if that makes sense. What are the business vocabulary that you have needs to be used? So the consistency comes from the same names, same words, same nouns being used to indicate the same things. You can't use things interchangeably. Most times in my systems, I'll use the word retrieve customer, retrieve order. So it's very clear that I'm retrieving the customer or the order from the system because get might be a little confusing in some cases. And there could be a difference between retrieve and search. A search implies, I'm not sure that this data exists. And if you don't find it, don't throw an exception. Right? Imagine going to google.com and if Google can't find something. Has it ever happened to you? It's actually happened to me. It gives me a blank page with some, stuff that tells me it didn't find anything. Retrieve customer says, if you ask me for something, a customer by a certain ID, let's say, and if I don't find that customer, I am throwing an exception. Because you're not asking me to search for the customer. You're saying, get me so-and-so customer. The system will in turn say, well, since you asked me for a specific customer by an ID and I didn't find it, I'm throwing an exception. Right? So there's a big distinction between retrieve and search. The name should indicate clearly what it is that it's doing. And talking about exceptions, in my systems, there's a facade as the sort of the point of entry. So if you're seeing this diagram up here, the facade is the input is on this side like that, right? So the input is on this side like this. So if this is your entry point and the whole system is behind on this side, then as soon as the request enters your system, so I'm not talking about the class in this case, I'm talking about the entire system, that black box. As soon as the request enters your system, by request I mean somebody calling your DLL and newing up your domain facade and calling a method on it, right? Or through a web API controller, you need to validate. You validate, and if you don't like something, just throw it out. Don't entertain bad data. Your API needs to be strongly typed, no strings. The API at the system level has to be extremely strongly typed. There's no leeway for loosey-goosey APIs, as I call it. So don't use strings just because you can. Make sure your APIs are strongly typed. That makes your API much more readable, actually, because it's not just a string. So is this a string? Do you mean like, is it an XML document in the form of a string, or is it a JSON in the form of a string? Like, I don't know, right? A strongly typed API makes the entire API much more understandable without documentation. So if your methods are named correctly and the arguments are strongly typed and the arguments are to the point, meaning what I call in PWI, I call it need to know basis, which is the method should ask for the bare minimum information, nothing more. And this is such a problem because people are trying to either prevent themselves from having to rewrite change the signature, for example, that they're imagining the extension, the extensibility, extension and reuse. I think that's one of my Let's Talk videos. Extensibility and reuse. Let's talk. No, thank you. I think we should have the humility to say I don't know. The more we think we can imagine the future, the more we can think we can imagine the extensibility, the worse it's going to get. So signatures, method arguments should ask for the bare minimum information. Don't imagine the future. Now, if you have a DTO, let's say you have a customer DTO in your system, and this is a huge customer. DTO meaning lots of properties, which is quite common for customers. They have lots of information and lots of header details, meaning multiple addresses, multiple phone numbers, and so on. If you don't need all that information, if you just need the customer name, let's say, or the customer email address, then ask for just the email address. If you need, like, let's say 4 or 10 properties out of the 200 properties a customer might have, you define a specialized DTO that asks for just those properties. When everyone sees your API, they'll see that you have some DTO. And if they look at the properties of the DTO, they'll say, oh, yeah, you don't need these 5 or these 10 properties. You don't need the 200 properties. And because you're only asking for these 2 or 5 properties, it becomes easy for me as a consumer to understand what is it that you might be doing with that data. Right? It's not unknown limitless data. It's just exactly these properties. So you ask for exactly what you need and nothing more. Please don't ask for things you don't know. When in doubt, leave it out. So when are you in doubt then? I know most of you are never in doubt, right? You always know. For me, if I don't know for sure, I'm in doubt. I don't guess. I don't imagine. If the requirement doesn't tell you anything about that right now, don't imagine it. So when in doubt, leave it out. All right. So if you have method names that are well chosen and you have arguments that are very specific, to the point, and need to know basis, as I call it, nothing more than they need exactly for that method to operate, for the method to perform the function it says it's going to do for you. Methods are either commands or queries. Commands are methods that do something. Queries are methods that get you something. Commands should do and not return. Command methods should do but not return anything. They should be void returning. Don't return error codes and a bunch of other. There's no need for a command to return anything. If you say delete this customer, it's gone. If it could not delete a customer, maybe let's say if you ask for the system to delete a customer, it's a problem. Normally it's not. I mean, if you ask the system to delete a customer that doesn't exist, the system has nothing to say. But as an example, if it had to say something to you saying, hey, I didn't find the customer. What do you mean? Did you mean 1 or did you mean 10? The system will throw an exception. So you'll know. If the system cannot do what you asked it to do, it should fail fast and fail visibly. Fail fast meaning at the point of entry into your system. Remember that domain facade and the point of entry. At the point of entry into your system, you validate. If you don't like, throw it out. If you couldn't do the job, throw it out. Don't be nice. Don't be coy. Don't just log it and say, oh, yeah, I'm done or okay or whatever. Fail fast and fail visibly, whether this is a system or a class or whatever it is. Now, in classes, I don't mean validate, please. I mean only in a system, you're doing the validation up front at the point of entry. The rest of the system has no validations in it. If you don't know what I mean by that, please look at that video that linked to up here where I talk about if you lock the front door and you lock the back door, you're safe in the house. The house meaning your system. So the locking the front door means You cleaned up any data that came into your system. Once the data has been cleaned and it meets your requirement or your specification, accept it into your system. If not, throw it out. From that point forward, from that entry point onwards, nothing, no classes need to worry about, no methods need to worry about invalid data or incorrect data, right? It's been done up front. Going back to the command methods and the query methods, a query method typically retrieves data. It does nothing. A command method does and returns nothing. A query method does nothing but returns data. You don't want methods that have side effects. We don't want methods that say, I'm going to get you a customer, but in the meantime, it's gone and sent off an email or something. Like, you don't expect that to happen. So methods should do exactly what they claim to do. If a method cannot return something that you ask for, let's say you say, get me customer 42. It can't find customer 42, it's going to throw an exception. It does not return. It throws an exception. It's not coming back saying, oops, I'm sorry, but do you want something else? Or a null customer. That's like the worst case. If a method claims to return something, it either returns that something or does not return at all. Simple. Keep it simple. This is all in the programming with intent video I had linked to earlier. Please take a look at that. I don't want to go into a lot of detail in this video at least. APIs should be easy to use and difficult or impossible to misuse. So you want to design your APIs in such a way, the method names, the signatures, the arguments, in such a way that there's no ambiguity, which is what programming intent is all about. Show me your intent, what it is that you want. What is it that you're going to be doing? What is it that you're doing if you look at the implementation of a method? Programming with intent is really about all of this. If you design your methods correctly, your APIs correctly, they'll be easy to use and understand and difficult or impossible to misuse, right? So that's one of the things you're looking at when you're looking at the core principles of API design. Most people should not be able to misuse your APIs. If you find somebody asking you for documentation, that's a problem. The problem is not them. The problem is your API. Your API should be self-documenting. Now, I can understand that sometimes there might be some reasons to document some things. Maybe just generally, in your organization, you're required to document stuff. What I'm saying is, if a developer takes a look at your assembly, right? That's the entire system, and they're trying to slap on let's say a web API layer on the top of that, or a WinForms application on top of that. They should not require documentation. It should be self-documenting. The API should explain itself, right? And it should be difficult to misuse, therefore easy to use and difficult to misuse. When you're designing an API, you should also go through a API design review, just like a code review, but an API design review. Now, if it's in a team, there are two ways to deal with that. Consistency and coherency are the key aspects of a system design. Code reviews are a medium by which we ensure the code written by every one of us is of a certain quality, of a certain opinion, and follows a certain principle within the scheme of things. You either have one code reviewer who you trust, who understands and is completely in sync with the expectations in terms of the opinions and the guidelines, so that at least there's a consistency in the way that person is looking at code, reviewing your code, as well as the API. If there are a bunch of people doing code reviews on the team, then you want to make sure that they are all on the same page. If there are people with different ideas, different opinions, your system is going to be a hash. So as much as it might be more efficient to have many people on the team doing code reviews and or API design reviews, it's important for the team or the people who are doing the code reviews or doing the design review, the API design reviews, to be on the same page, to form a coherent set of people who are all thinking alike, who all would find the same fault, would all have the same problem with something and they're not of differing opinions. So I know this is a tall ask sometimes, to have, but it's up to the people that know to then train others to be on the same page, right? So as a team, you might have everyone, a bunch of people, maybe the senior engineers as code reviewers. They're not necessarily making the final decisions, but by including them in the code review process, you are introducing them to how you think. Right? So if they should start catching the same kinds of things. They should have the same kind of comment. They should have the same coherent understanding of how you understand your thing. So it should be a coherent, cohesive API, whether it's a class design or a system design. And so it's important to have this consistency with regards to how you think about your API. Now, when it comes to web APIs, let's say, because I'm calling out web APIs specifically because you're typically dealing with data going across the network. Maybe the same could be said about your access to your database. Maybe I can talk about that separately after this one. When it comes to web API design, now the controller is simply surfacing the API of your system. With services, there's a conversation that people have or a statement people will make. Design coarse-grained APIs, not fine-grained APIs. Now, I like to be a little more specific. I love these terms, but if they don't mean much, and when it comes down to implementation, you and I can implement things differently because the term is vague. I'm not a big fan of those kinds of things. I need to be very specific, so I'm going to get specific. I'm hoping you understand when somebody says build a coarse-grained API versus a fine-grained API, what that means. Essentially, what it means is because you're going across the network, you don't want to have APIs such that for the normal kinds of things, your consumers have to call your service 2, 3, 4 times instead of just once, right? So a fine-grained API is something that says, okay, first do this, then call that, then call that. But from a business standpoint, I need to call those 3 or 2 or 3, 4 endpoints every single time because that's just how it works, right? You've designed your API in such a way that you're forcing people to call your API so many times to do the normal things. While a coarse-grained API is saying, well, why are you making people call your system so many times? If you have a business functionality that is required to be done, then maybe it should be one method call. That's it. So when you make one method call, it's done. It's a coarse-grained API. Right? You're not forcing people to call 2, 3 endpoints to get the one thing done. The example I give people at work is typically like this. Now, I don't know if things have changed in India since I've been here in the US. I'm sure they have, but I don't know how different it is. In India, when I got my license, this was years ago, decades ago, you stood in multiple lines with different forms. It wasn't clear what it is you needed. So you waited all day in a line and you got to the end and the lady or the person would say, where's your so-and-so paperwork? And you come back the next day and you stand in line and repeat the process. So it's not clear what it is that these people wanted in each line. And once you stood in this one line, you went to the next line and stood in that line again. And so those multiple lines, multiple people, each person had different requirements, different paperwork. That's a fine-grained API. I'll give you a coarse-grained API example. In the US, when I came here, your number was called out. You walked up to the counter. Before that, there's a form that tells you exactly every piece of paper or documentation you're going to require in order to get a license. Now, that was the requirements. That's the method arguments. The method arguments are saying, I need all these things. And it's very specific. It's not like get me, all the other paperwork just in case. No, I need this and I need that. You walk up to the counter, the lady, the guy there will say, take all the paperwork. Now the person behind the counter is going to go places. Going to make a copy here. He's going to do this. He's going to file something there. Come in and out comes a license. You stood in one place. So I went to the window once with everything that was asked of me as a method signature, if you will. And the system did all the heavy lifting of going here, there, and doing all the different steps behind the scenes. And then I got a license. Of course, that license part is I had to go give a test to. But what I'm saying is, it was a one-stop shop. And every piece of information that I was ever going to have to furnish was made clear to me before I even got to the counter. So that's the difference between a coarse-grained API and a fine-grained API. The second was the coarse-grained API. The first was a fine-grained API, example of a fine-grained API. Now, continuing on with the fine-grained, coarse-grained discussion. When you're building services, it becomes critical to design coarse-grained APIs. So in some ways, that statement is correct. But I'm going to now dice it up a little bit so you understand exactly what I would do, because it's not coarse-grained all the time. I call it correctly grained APIs. If the system, for example, you're building a part of the system that's handling, let's say, customers, and customers would like to add new addresses, make modifications to addresses, add new phone numbers, make modifications to existing phone numbers, and so on and so forth. A coarse-grained API would say, and at least this is how people see it, and I've seen many systems built like this, which is why I'm bringing it up. What they do is they say, well, this is a customer. This customer is this huge object. It's got 200 properties, let's say, collections and collections, collections of addresses, collections of phone numbers, collections of email addresses, and so on and so forth. That DTO, or the data required to create a customer, is a massive set of data. And so what they're going to do is they're going to define an API that takes that whole thing, the entire customer. If you want to update something about the customer, there'll be another endpoint that says here's an update customer, and you give it the whole customer again, even though you just modified a phone number. The API is not fine-grained, is coarse-grained, because that's what they listen to. They listen to saying build your APIs as a coarse-grained API rather than a fine-grained API. What I'm telling you should do is this. If the business requires the system to allow a customer to update just a phone number or add just a phone number, then you need to have an API that allows you to do just that, which is give me the customer key, give me the phone number, give me the type of the phone, for home, cell phone, office, whatever, and I'll create a phone number for that person. But that's all I need to create a phone number. I don't need the entire customer to create a phone number. Make sense? If the business has a need to allow a customer to modify an address, then of course you say, okay, what address do you want? Home address? Okay, here's a home address. You want to make a change? Sure, make a change, hit the save button or update button, and I'll do the rest. Your API is just asking for the customer key, let's say the address ID of the pre-existing address, and the data for that updated address. That's it. You don't need the entire customer to update an address of a customer, right? Some people call that a fine-grained API. You're going to give an API just to modify a phone number. You're going to give an API just to modify an address. You're going to get an API just to do this or that. Those are fine-grained APIs. You should be building coarse-grained APIs. I'm saying, no, I'm building the right-grained APIs. Your APIs have to be as per the requirement of the system. So don't get hung up on the coarse versus fine-grained, even though there is some truth to that. Keep your eye on the ball. What are you building? What does the business need? And the UI will drive a lot of the APIs you require. So make sure your system is conforming to what the business requires, not your own idea of what a coarse or fine-grained API is. But there are other advantages to that. Performance. These are systems working across the wire, HTTP or whatever other protocol. Network I/O is the slowest aspect of our systems. The least amount of data that you can send across the wire, either from the client to the service and from the service back to the client, the more efficient and performant your system is going to be. The less network traffic you use, the less network bandwidth you're using, the more traffic can travel on the same network. Therefore, you're not choking up the bandwidth of that network and then preventing or causing pain for other systems in your network. But also because of mobile and various other devices being sometimes limited, your system will still be performant, still react in small amounts of time because it's shuttling little data across the network. Which also says when you're designing an API, let's say, you say, get me customer 42. Now, maybe that's too generic because Are you saying get me customer 42 and all 200 fields, or are you interested in just the address of the customer? Are you interested in just the phone numbers of the customer? Are you just interested in that header information, if you will, of a customer? So you might have to have APIs that allow people to tell you specifically what they want. So you're not just shuttling the entire customer every single time somebody says, get me these customers. Let me get me all my customers from the state of Florida. Do you want their names? I mean, like, what are you doing exactly with it? Do you want to send them an email? So if you make APIs that are specific, people consider them to be fine-grained. I'm saying no, they should be the right-grained APIs, correctly grained APIs. If the need is there for you to get a subset of what you would call a customer, where it's just a customer name and a home phone number, or a home phone and home email address. So let's say there's name, home email address, home phone, cell phone, and home address, postal address of the 200 other properties, then yeah, make an API that very specifically gets you that kind of that information for the customers given some criteria. What about when you are inserting said customer, updating said customer? Frequently, we would have a DTO in our systems that represents a customer. All right. Let's say, for example, this DTO is this 200 property customer. And one of the properties in that customer is the ID or the key or whatever the identifier is for that customer, right? When you insert a customer, when you're creating a new customer, what do you ask for? That same DTO? I'm saying no. I'm saying you want specialized DTOs for the specialized operations. Don't get hung up on the fact that I already have this customer. So now, for the sake of removing one property, let's say as an example, I'm going to create a whole other customer. Now that's hardly likely, but I have multiple DTOs for insert, for update, and for create. So at least these three for every entity in my system. By entity, I don't mean like at the database level, like what I consider in the system, a customer or an order or whatever it is. To me, that's an entity. I could have multiple variations to this entity. I could have this entity for create. I'm actually going to call it for create. Customer for create. Show. You're building a site that has shows. Show for create. Show for update. Show for delete. Now you don't need a show for delete to be just the ID is good enough. But show for create, show for update. Definitely. Because they are different. In one case, you may not have the ID because you're creating it. Where's the ID? What ID? If your API is asking for the ID as part of its signature, I'm saying that's incorrect because you're supposed to design methods that are to the point. Ask for exactly the information you want and nothing more. If you don't need that ID at the time of creating that customer, don't ask for it. It's just going to confuse people. Should I send you a -1? Should I send you a 0? And then, what's happening is people will say, I tried the -1, it worked just fine. So maybe you should do the same thing. And then somehow it becomes the standard. Just send a -1. You're supposed to send a -1. Don't confuse people. Just take that ID out of the picture. You're creating a customer. Now, that's also one of the cases where there's an anomaly where I say, methods that do should not return. The inserts are typically those anomalies where you do return the new ID. Right? So that's one of the only times I've ever had to break the principle of saying commands do and return nothing. They do, as in this case, you're creating a customer and you do return an ID. Not to indicate success failure though, but to give you the result of that creation. In this case, there's an ID to be given back. So you do return. All right. So I think this brings me to the end. I will, at some point, we do plan to have a project that we're working on. So you'll get access to all of this by way of the exercise we do in the project. But eventually I'll also make that code base available to the public, put it on my GitHub, and that way, and I'll link to that from this video, but it's going to be a while. So if you're watching the video now for the next, 2 or 3 months, there may not be any sample code available. But if people are interested in knowing something, or if I have not explained myself clearly in this video, please ask in the comments below and I'll answer that. And there may be follow-ups to this video just because this is a huge topic. I'm trying to keep it to the core principles, but people might start asking me questions that I may not be able to just answer in the comments. It might warrant another video, right? Okay, so that brings me to the end. If you've reached thus so far, please subscribe. Please give me a like if you like this video, and I will see you next time.